This is episode 1. This is episode 1 of Data Science and Machine Learning in Practice. And I want to design a recommendation system in this episode. So, talking about what is recommendation system, let me tell you, YouTube uses recommendation system to suggest us to watch any video just next to video what we are watching currently. While purchasing something on Amazon, we see Amazon is suggesting us to buy this one also or look at this one also. So that is the recommendation system which is running in background and discovering or doing all the research and suggesting us to buy that product also or to look at that product also. Also, while watching movies or shows on Netflix, we also see Netflix suggests us to watch something on their site which is very similar to the content which we are currently watching or which we may be likely to interested in watching that content. Again, while browsing Facebook, we also see Facebook suggests us to like any page or join any group. So in the background there is a kind of research going on about what to suggest to user, and this research is actually done by recommendation system. And we also see this kind of recommendation on blogs or any sites where we read articles, and all these recommendations are done based upon a research in background. So this kind of research is done by recommendation system. Now in this episode we will be doing this research and we will build our own strategy about how we can recommend to users to buy something or watch something, or we will just implement a strategy and you can use that strategy to whatever you want to use. So the technologies which we are going to use will be Python 2 as our programming language, and again pandas is a package which comes with Python, and these packages are usually used to play around with data, and we will use NumPy. NumPy is again numeric Python, we say that so, and it is used for a lot of scientific calculations. Again, if you don't know about all these technologies, I don't recommend you to go to their official site and read all the documents and all those things. When I will use any function of that package or anything like that, I will talk about that, what is this and what is that parameter, or what it does and what is its function. So if you want all these packages at one place, I recommend you to download in Thought Canopy, and in Thought Canopy will come with IPython notebooks, and IPython notebooks are kind of interactive Python. We can run our Python code directly in browser and see output on the directly on that in browser. So I am going to design a movie recommendation system, and we have downloaded data from movielens.org, and we will be using all that data. So before I talk about a strategy, let me show you about the data and what we are going to interact with. So here is our data, and the first table is this, and in which we have a movie ID and a movie name, and then the time at which this movie was released, and a link to IDMB about this movie. And another table which we have is user data, and this contains 4 tables, and the first one is user ID, second one is movie ID, and the third one is the rating which is given by this user to that movie. And again, this is something we are not going to care about, because that's what we are going to use in our strategy. So this is our data. Let's come back to our discussion of talking about our strategy of building our movie recommendation system. So first we will take all the data in terms of rows and columns, then we will extract the rating of Star Wars from all those rows and columns, then we will correlate the rating of Star Wars with the rating of other movies, then we will see how similar rating of those movies are compared to the rating of Star Wars. Well, the thing to notice is that we are going to consider only one user. Means there is an user A and he has given a rating of 4 to Star Wars, and the same user is giving a rating of 4 to any other movie. We will think that these both movies are somehow related to each other. Again, we are going to simplify things, so we are considering only this much into our mathematical model, but to make your actual implementation much better and mm, giving to make it more correct results, you can consider a lot of variables, like what is origin of that movie, what is language of that movie, what is origin of that user, and a lot of things. And finally, after calculating correlation of rating of Star Wars to other movies, the most similar rating will be our answer. So let's write some code and implement this strategy and see what we are getting in result. Let's import pandas first to take data into format of rows and columns. So import pandas, we will call it pd for short, then we will take a variable with name r columns, and this variable will contain user id, then movie id, and the rating given by that user to that movie. So it will be rating. This is going to be the columns in our table, that is user id will be a column, movie id will be a column, then rating will be a column in our table. Then let's load the data from our data set. So we will call it ratings dot read ratings read csv. This read csv is a function that comes from pandas, and this function is used to read data from any csv file and take all the data in a format of a row and columns based upon the separation parameter. So the first argument to this function is the path where the data is stored, and on my machine this data is stored in H drive and data science folder, and again I have a folder or subfolder called ml100k, and the name of that file is u.data. Okay, and the second parameter to read csv function is separator, by which the data into that file is separated. So we saw that our data is separated with tab and that in that particular file. Then we will give the names which we want to give to columns, and we have already decided that we will call that user ID, movie ID, and ratings, and this all is a Python list and it is stored in R columns. So we will give names will be values which are stored in R columns. Then we want to use only first three columns, or we want to limit read CSV to read first three columns and load that a table with names of this. So we can say, or we can instruct Panda to do something like this by saying use columns and only three columns. Okay, let's do something very similar with movies, and I want to call that m columns, and we will have a movie ID, then we will have a title of that movie. For now I just want to load only this much data, and let's load the data using read CSV of pandas. So pd dot read CSV, and let's give the path is in H drive, in data science folder, and in ML 100k subfolder. The data is with name u.item. This path can be different on your machine depending upon where you have stored your data. The separator in this file is a pipe sign. This is your pipe sign, and we want to name these columns with these names. So we will say that the names will be m columns, and we want to limit to read only first two columns. So range will be 2. Okay, fine. Now the good thing about pandas is we can merge two columns into one and then make it more meaningful. So let's merge these two datas. So ratings is equal to, I am merging this data into this data. So again pd dot, that is pd is this pd, and pd dot merge, and what I want to merge is movies and ratings together. Okay, fine. So what merge function of pandas will do is merge this data and store finally into ratings. So let's run this much of code. Okay, this is fine, and now see what we have in our ratings. I am running this. So we have this is in our ratings, and the ratings is movie ID is 1, and the movie name is this, and user ID 308 has given 4 rating to this movie. Create a table in which I can see which user has given what rating to which movie. Again, pandas make our work very easy, and we have a function called pivot table, and we will use that here. So we will name our table movie rating, and in our table the indexing will be based upon user ID. That is, I want to see a rating by each and every user. So I have to index it on basis of user ID. Then I need column, and I want only columns based upon the title. Means the name of columns will be the title of the movies, so I have to say that. And this is actually given as a list, so we give that. And I want to fill it with values of ratings, so the ratings will be the rating given by user to that movie. So let us run this. Oops, I think I made some mistake here. Okay, let's fix it. So it is actually, I need to explicitly say that what is user ID. So indexing is user ID. Now I think this will work fine. Okay, so see what we have in our movie ratings. Okay, you see we have 664 columns. That means we have that much amount of movies, and we have 5 rows. This means we have 5 users which are rating all these movies, and this NAM means not available. That is, user 0 haven't given any rating to till there was U movie, but user 1 has given 2.0 rating to 101. I don't know what is this name, but user 1 has given some rating to this movie, and user 1 has also rated Angry Man movie with 5 rating. But same user haven't rated yet to these movies. So NAN means that this user, that is the corresponding index, haven't given any rating to this movie. So let's extract the rating of Star Wars. We want to suggest user if he or she is watching Star Wars, so we will extract the rating of Star Wars and we will work on that. So let's take a variable called Star Wars ratings, and movie ratings, and the variable name is Star Wars 1977, and okay. So let us see what we have in our Star Wars ratings, that is who has given what rating to a Star Wars. So you see we have 5 users. We have given ratings to Star Wars, and user ID 0 has given a rating of 5 to Star Wars, 1 has given a rating of 5 to Star Wars, 3 haven't rated it, and 4 has given a rating of 5 to Star Wars. And now comes the interesting part. What we will do is check the rating of Star Wars and then correlate its rating with rating of all other movies in our dataset. So again here pandas will do our work very easy. So we will take a new variable called similar movies, and this will be the movies which are correlated with Star Wars. So we can do it like this: movie ratings dot corr with correlate with. This correlate with function comes from pandas, and the correlation to take care is this correlation, that is Star Wars ratings. So let's put it here. Okay, fine. Now I don't wanna mess with the values which are not available, so I want to drop all those values. So I can do it like, similar movies will be similar movies dot drop na. Again, drop na function comes for pandas, and this will drop all values where there is no value available. Finally, we will create a new data set, that is we will create a new data set, data frame, and this data frame will consist of similar movies, and this will show the correlation of this data frame will show us the correlation of Star Wars with all other movies. So let us run this code and let us see what we have in our new data frame. Oops, wait. I think there is something. Okay, we should have done it like this. This is complaining about this. Okay, now we can run it again, and let us see what we have in our new data frame. So okay, so we have this in our new data frame. I don't feel good about this, so let's see first 10 values. Yeah, okay, so now we can see first 10 movies, and here we have first 10 movies and their correlations with Star Wars. Now we implemented our strategy, so let us see the result of our strategy, and we can get it by this: similar movies, and I want to see the results with highest values on the top, so I have to see it by this way. This function comes from pandas, and we have to explicitly say that I don't want to see it in ascending order. That means the value with highest value should appear on top, and that will be false. And Let's try running it. Okay, so we see these movies are how related to Star Wars. How reality is Star Wars and Man of the Year, Full Speed, and all these movies are very similar to Star Wars, and while other movies are not similar to Star Wars. Okay, but one thing to notice is that Man of the Year is a kind of obscure movie, and we don't yet know about that. And I don't feel like it is anyhow related to Star Wars. Also, Full Speed, Mondo, and all these movies are not anyhow related to Star Wars. So, what's wrong with our strategy? Can we do something better than this? Because our result is not feeling like meaningful enough to, take it as the final result. So, being a data scientist, we are supposed to consider more variables and change our strategy so that we can get more meaningful data. Let's talk about how we can improve our strategy and what was wrong with our initial assumption. We were assuming that every user which watches Star Wars and gives a rating of 4 or 5, and the same user is watching other movie and giving the same rating to that movie, then those two movies are similar. But in real life, taste of any user varies. Sometimes it can happen that any user watches any science fiction movie and gives a rating of 4 to that movie, then he watches another movie, any horror movie, and gives a rating of 4 to that movie as well. So that can happen because of change in taste, and this is very common and normal in real life. So we were not assuming this on our strategy, and that's why we were getting obscure results and not meaningful results. So here we will improve our strategy by setting up some threshold of ratings so that we can see, because if a lot of people are giving same rating to two movies, this means somehow these movies are related. But if only one or two man is giving same rating to that, to those movies, then we cannot actually say that these two movies are related, because this can happen because of change in taste. So we will set up a threshold in our new strategy, and we will create a new data frame based upon how many users rated that movie and what is the average rating of that movie. So we will consider average rating of a lot of users, then this will set a kind of threshold to consider which movie is related or correlated to which movie, and we will take only those movies which are rated by at least 100 plus users. Then we will sort the results, and the most similar or the most correlated value to our Star Wars movie will be our answer. I want to consider two parameters now. The first one is how many users have given rating to that movie and what is their overall rating. So we are going to use NumPy for that purpose, and this will be like import, and for short we will call it NP, and the new variable will be movie stats, and this will be grouped by title, and the aggregate of rating. And how many users have given rating and what is the average of that rating. So okay, and let us see what we have in movie stats. So here you see we have these movies and their mean rating means till there was you has been rated by 9 people and the mean rating is 2.3 than all these movies. So we want to get rid of movies which are rated by which are which are not rated by at least 100 people. So this will be our threshold that we will consider any movie in our consideration only if it is rated by at least 100 people. So we can do that by taking a new variable popular movies, and popular movies will be movie stats and rating and size, that is how many people have given rating to that movie, should be at least 100. Now let's sort the values based upon what is its rating. So movie stats and popular movies dot sort values based upon rating and the mean value. And I want all these results in descending order. So I have to say that ascending should be false. And let us see only first 15 results. Okay, so we have all these movies and this movie has been rated by 112 people and the average rating is 4.49. so this looks a really good movie. Now what we can do is we can find out the movies whose rating is correlated with the rating of Star Wars. We can create a new data frame by this and movie stats, again popular movies dot, we want to join it with the data frame of similar movies and columns should be based upon similarity. Okay, fine. Let us see what we have in this data frame. Okay, this looks good because I think it is in ascending order. So we want to see it in descending order. Let us do that and we'll see more meaningful result. Sort values, and sorting should be based upon similarity and the result should be in descending order. Okay, fine, and we want to see only first 15 results. Let's try running it. Oops, I think I made some mistake. Well, ASCE and DING, and this is okay. So we see Star Wars is very similar to Empire Strike and Return of Jedi, Riders of the Lost Ark, and we see its similarity score, and this looks very meaningful result. So this was our recommendation system, and you can improve this strategy by using other variables like what is the origin of movie, what is the language of movie, what is the origin of users which are rating to that movie, and a lot of variables. But for simplicity we have assumed only what is rating being given by average users to that movie. And you see how we improved our result by setting up a threshold of 100 users, and this threshold was okay with this data, but you can improve this kind of results by setting up different thresholds. And so thanks.